Today we're going to talk about technologies and the number it affect our looking for new technologies to serve our need. Uh, in this session, we're going to talk about overheight vehicle detection. It's blank. One more. One more. All right. We've been noticing that 2014 we have 35 reported bridge hits during the overheight vehicle load. 11 for them is during the peak hours, more than any of the last 3 years, which is the previous 3 years for all type of bridge hits. Majority occurred inside 610. That tells us something. Inside 610, I-45, near downtown. Cost, we're looking for cost, 200 to 300K. If you just make a small mess, that's about 10,500,000 a year. That's one item's bridge hit. Since 2012, overheight permitting required for loads higher than 14 feet have become online, self-reporting. So unlonely, or people knows or doesn't know, they just check mark on the 14 height, they get the permit online, and we have been working on this project. So we visit a couple of dealers, cars around us, they carry those loads, and we find that is not most of the people known what's the height they drive on the freeway, and this kind of surprise. Some of them they are aware of the heights, some of them they not. That was kind of permitting online. It's just a simple people, they just check mark, I'm okay. They drive, they hit the bridges. So we can see the difference now between 2012, since the permitting came up online, and 2014, which is 35 reporting bridge gets hit. 59 south westbound is about 14.2. That's the height of the bridge, 14.4. See how it's low there. We have a lot of all the design. It does not clear like a new structure now. We see in 18, 20 feet clearance, but we still have a lot existing, very low clearance and 14. And this is one of the issue we dealing with the bridges right now when we talk to them about when the last time we measured those physically clearance, what's the offset, what's happened, maybe settlement in the ground, it make that clearance a little bit lower. We need to more study on those issues, but this is the fact. We have 14.4, one of those clearance here. So we have to come up with something, study those, what's happened, how we protect it, or actually to tell the trucker, you're gonna hit one of our bridges. You're gonna cost us so much money if you going through this route. We've been selecting 2 demo sites, and the majority we try to avoid or try to tell the trucker, do not go to downtown, especially to those routes. So outside the loop 610 inbound, especially before they come up to the downtown area. And the selection came up on I-10, one in east, one in west, and it's about like 2 miles from before they hit the 610 loop, which right here. And this is one of the selection, and one in east, one in westbound. And we selected those 2 sides, one in I-10 west and Wert, if you're familiar with I-10, and most of us familiar with I-10. And the other side is from I-10 and Mercury, that's an east side. Now we said, what we should do? We're looking for a market, it's like we research many sites or actually industries who does the system, how we protect it. And we selected to actually double beam. I'd like to go to the next one showing before we target the, this is the cut sheet of the specification for the trigger manufacturer. And I'd like to point some kind of, we need to comply with, we have a freeway 4 and 5 lanes, an I-10 6-lane. So we select one of the dual beam, that is a red Z pattern, a switch to a single beam. As we know, this infrared, it's sometimes it's reflecting by the sun, reflecting by the weather. So that's the reason we have selected dual beam. And if it's one over, just for protection, if it's sun is or other interference effect. The other point, I went back. Anyway, the other point for the selection, this type of detection, is we have a certain limit, 200 feet to cover in our freeway. The third important point where we selected this is the speed. If we have 1 to 75 miles per hour, that sensor can protect 2.5-inch diameter. That by itself is very important because we have so much carriers to oversect antennas. Sometimes it hit the bridge. Small object, it hit the bridge. So we need to select something very sensitive to that kind of diameter, or small 2.5-inch diameter to be selected. So this is one of the dual beam here is being selected, the active infrared direction scanning system. And what we're going to do, we need to tell the people or tell the driver as a warning. So we activate this activate camera and the dynamic message sign integrated with each one of those overheight vehicle detection. TTI complete their performance evaluation study. And this is the cut sheet, like I mentioned, it's with the information about the dual system. Now we talk about what limit we're going to set this sensor. I would like to set kind of story. It's very funny. When we start up doing this one, we set the system at 13.9, and I get those alert in my personal phone. So every night, my wife said, "What this?" You know, and she asked me, "Please, you know," I was like, "Do some." We couldn't sleep for the last first 3-4 days because the number of the vehicles, it hit the 11.9. And she didn't want to take a dot alerted in home and next to our bed. Then we realized that is because we have the lowest height, it's 14.4, so we increased the threshold to 14 feet, and that working a lot better. And they give us, we still have numerous numbers of alert every day. So the system work whenever the threshold met or exceed the automatic alert of violation will be text, emailed, and video upload. Which system actually, that get me to the next, I'll showing you how the system component is. Additionally, downstream flashing beacon and warning message will automatically be activated. The component of the system, as you see in this graph, is simple, but it required many attention to the height we said those dual beam. So point A, where is the overheight vehicle is detected. Point B, the alarm bell. This is the old style bell. I don't know if you guys remember, we used to have one of those ropes and bells on the top, and if you hit me, the meaning overheight. Diggling ones. That's the same one. And on the C, we point, that is our warning for changing direction. So this is a typical installation we did on I-10 and Mercury. And as you see, this is between, this is wrong one.
Is the top one there's an arrow?
Yeah. But here, as you see, this is the dual beam on the demo site. And it is set at 14 feet height. And right on the top of that, we find the camera. And this camera, really innocent, they send us on the alert 5 pictures live. We can get the type of the vehicle, what's manufactured. There's a lot of information. We can get those pictures. It's sent up on our alerts. And at the top, you will see type of antenna. That is what's sending the closure contact to the dynamic message sign for warning the people to change the route to 610. I wish we can use a vehicle shell, but we don't have a word shell on our system, so we said must go to 610. That's what I meant, it's like, unfortunately, but you will see there's a lot of good result for the system, and we have been dropped the number of the vehicle. That is what Roma, she will talk about it. And I'm not quite sure. I was looking for myself in this picture. I don't think so. I'm here, But the installation, it takes for us about 2 months, and we was able to receive data right on the spot, like we said, and TTI helped us a lot to get this performance and the result. So the installation started on January 5th in 2015, and the deployment tested, it's February 7 to 8, and final dynamic, the overheight vehicle detection performance evaluation, it was in August 31st. It's very, very fresh. By that, I will turn it to Roma from TTI to talk about the result, and thanks you all for listening to me.
Good man, good man. It's very good.
All right, so since this was a demonstration project, so TechStart wanted us to do an evaluation, and thank you. So this was a pilot demonstration, and as far as we know, there's not a similar system anywhere in Texas. So for the evaluation, we wanted to look at both at the technical operations of the system and the effectiveness of the system. And then what are some of the institutional lessons we learned from this? And what is the cost effectiveness of the system as well? So our process was basically collect the before and after data, and before data it included the alarm emails. We started with the text, like Magdy explained, the texts were just, we were getting way too many texts for us to handle. So we discontinued that right after, I think, about a week or so. And then we got the video data at the interchange so that we could match what we get at the sensor to whether the vehicles which are overheight are going straight on I-10 or they are taking the 610 loop, because as you saw from the DMS, the intent is that if an overheight vehicle is detected, the message says take the I-610 loop. Do not continue straight, because we have low clearance bridges along I-10 and I-45 in the downtown area. And then we got the bridge hits data from Mike Petrick, and then the OVDS cost data from TechStart, as well as the modem logs for the alarms. We collected that. And these are some of the dates for which we collected the data. Actually, the data was collected for 2 weeks for the before period and 2 weeks for the after period. Some of the sample violators, so we saw all kinds of trucks, the box trucks and the car carriers, just something different.
Oil industry.
Yeah, just
Rigs.
big rigs, some different loads, more car carriers. kind of similar things on I-10 West, just to give you a sample of what we saw. And then the general characteristics in terms of, before we set the system, Mike and I and Magdy, we were all betting how many alarms we will get. Because we came up with, 10 max, and, well, we got about 70 a day on I-10 West and about 30 to 35 on the other side, the Mercury side, which was quite surprising. We thought we'll get, at 4, 5, 10 was the maximum number we came up with amongst us. We really didn't think there were that many trucks out there which were over 14 feet. And then what we found, this is one of the examples from what we get from the emails. The first picture is the first one you get, which is taken right when the alarm is triggered. So over here you see one truck. Look at the second picture. We have another car carrier here. The third picture, which is at the 3rd second, I got 1, 2, 3, and the 4th picture, have another truck. So one of the things we found from this evaluation is, if you have multiple trucks, once the first truck, which is overheight, now in this case, most likely it was the car carrier, which hits the alarm, it puts the sensor into an alarm state for 10 to 12 seconds. While the sensor is in the alarm state, no other overheight vehicle can be detected. So in this picture or this email, we don't know if this 3rd truck was also overheight or the 4th truck was also overheight. It could be. Another thing it doesn't do is we cannot tell if the truck would be in lane 1, 2, or 3. It could be anywhere. So it cannot detect the lane, and it cannot detect another overheight vehicle while it is in the alarm state. And it doesn't measure the actual height of the vehicle. It only, as soon as it breaks the 14 feet threshold, it could be 15 feet or it could be 14.1. And then for the DMS integration, basically the way it works is OVDS detects the alarm, the contact closure sends a signal to the radio receiver in the DMS. Radio receiver is preset with the alarm time of 30 seconds. In this case, it can be a different time. And then it triggers the message display, and the DMS stays on for the time the alarm is set. For the pilot demonstration, the way it was set, it only stays on for 30 seconds. It does not get re-triggered if a second vehicle is detected between the 1st and the 32nd time period. But we were told by the vendor later on that it can be changed. The institutional lessons learned were plan additional time and budget for procurement, especially if the product is not on the spec list. 2, very important to know the actual bridge clearance versus the marked bridge clearances, especially from setting the threshold perspective, as well as if you have to integrate it with the enforcement program. Then cell communications in the urban area, they are very reliable, and they provide a convenient and less expensive way to deploy such systems. We really didn't have any issues with the communications. And then effectiveness in diverting overheight vehicles, we saw a 5% increase in compliance at both sites. The increase was statistically significant at 90% confidence level, but not at 95%. And then about the bridge hits, that was the basic purpose. We should reduce the number of bridge hits. So for the Mercury site, which was on the I-10 East, the before period, there were 4 hits, in the after period, 0. On the other side, 2 in the before period and 1 in the after period. But before we get too happy, the overall bridge hits in the Houston district have reduced from last year to this year from 13 to 2. So we would like to take all the credit, but we don't really know if we should take all the credit. We should, okay? And the cost of the OVDS system is $135K per demo site. And the average cost, if we, as Magdy was mentioning, is about 200 to 300K. So if we take all the credit for saving the bridge heads, we have a benefit to cost ratio of 3.7 with the lower estimate of 200K and a higher estimate of 5.5. And it is, though we would like to add here, it is likely that people have, all the drivers in the area have heard about the system, and so it's just reducing the bridge hits in general in the Houston area. They have become more cognizant of their heights and take different routes. And going forward, we'll say develop a plan to integrate the system with an enforcement program. And when we're doing that, we also need to look at the technical funding and legal issues that would go along with that. And then continue monitoring the bridge hits so that we can better document the benefits. And then need to develop an updated and accurate bridge clearance inventory, which is very, very important. And then conduct a study to determine if OVDS should be deployed at other locations since the effect seems to be positive. That is all I have.
Are there any questions for Magdy and Roma?
Can you describe the signing setup? Was there an advanced sign prior to the detection and then the DMS sign, or was it just, okay, we detected the vehicle and then it had a DMS sign?
That's what it was. We just detect the vehicle and we just have the DMS. There was not an advanced signing. Anybody else?
I want to make this claim that we don't know why bridge hits went up so much during that time frame. Could be that the oil removal going on, the oil equipment going through the Houston area. We did mention the going to online, so we don't know if that was going on out here.
One other thing is that we enjoy some kind of relationship with the sheriff's department and then the local law enforcement there, and the truckers, the towing association, and they passed this along that we were having two things deployments, and people became aware that if you see the flashing DMS that you had to go around 6 them or hit the disposal.
Can you elaborate why this was different than old deployments?
Yes, yes. Thank you for bringing that up. This deployment looked at was intended to say more than one bridge because it's meant for all the bridges inside the loop, not just for one bridge. So it was unique in its application. That when we are telling at I-10 at Wood that take the I-10 loop, a driver might know his actual height and still might decide to go down I-10 because he's going to exit at the very next intersection, which is TC Jester, and it does not have the height restriction. So the familiar drivers who already know that what their height is and where the choke point is, they still sometimes would decide to go through and take the exit before the choke point.
Another unique thing about this deployment was it was over, what, 8 lanes? at the time?
Yes,
Yes,
yes.
2 lanes of traffic, which is a big difference.
And that's why it's important that it doesn't really detect the lane from which lane you are at. Some of the connected vehicle stuff is looking at overheight detection, but I'm not sure if the current sensors can detect which lane that vehicle is or which vehicle is the violator. So it would be hard.
Any other questions?
I'm just curious, has there been any thought about doing traveler information? So maybe you have like some of those signs that list maybe the low bridges, so you have the 3 low bridges, and then in terms of advanced signing of the detection system. You know, so you're going in from the I-10 and you know what your 3 worst bridges are downtown and you list those heights in advance of the detection system.
Yeah,
Advanced traveler information system for overheight vehicles. Like,
it could be, but it would be somewhat of an information overload for the driver. If they are really not familiar and then you are giving them the information about what bridges are low clearance and then you are, to me it would be You're trying to decide where those bridges are. If you're not familiar, is my destination before those bridges or after those bridges? So the safer route would be if you are trying to go downtown and you're over high, do not do that.
We could put up a sign saying, there's load restrictions, but nothing over 13 and 6 inside of 610 meters. Sort of like our hazmat, they don't follow that.
I mean, actually, inside the city of Houston, they are supposed to get a permit if, they're actually not even supposed to travel if the height is over 13.6. But we are getting overheight vehicles which are over 14 feet, and they are still going in the city limits.